All right, so today we're going to start by talking about classifying angles. We kind of touched on this yesterday. You guys talked about the 4 different types of angles. What were they? So you can tell me one. Yes. Straight angle. Obtuse. Jasmine? Acute. A right angle. Very good. Okay, so we talked about those 4 different types. That's what we're going to see. All right. So, an angle, the definition of an angle is 2 rays that have a common vertex. 2 rays have a common vertex. And these rays, okay, it's pointing right there so you guys can see with those arrows, but they're these that extend. And rays extend, they don't end. Okay, so just because it's ending right here, okay, you can actually extend it further. So when we start measuring with a protractor, if you don't feel like it's far enough for you to be able to tell what the angle is, you can always just extend it. Measure with a ruler, extend your ray. Okay, the vertex is this pointed section right here where the 2 rays meet. Okay, a lot of you guys just call it the point of the angle. It's actually called a vertex. Okay. There's 4 ways to name an angle. Okay, so if you look at this angle here that we have, we can call this angle 1. Okay, and if you notice, I have a 1 right here. Because what it is it's this space that's in here. That's what we're measuring. Okay? A lot of times I think people think that we're measuring the distance from here to here, and it's not that distance, it's this space from here to here. Okay, so that's what we're measuring. So, we can call this angle 1. We can call it angle Y. We could call it angle XYZ, which means we're talking about X, Y to Z. Or, we can call it angle ZYX. So if you notice, what is Y? That middle letter. It's the vertex. Very good. That's up to you. I'm not going to stay on here very long, though. Okay. So like we said yesterday, we have our right angles, which measure exactly 90. Now, do you see this little box over here? This box right here? Okay. If you see that box, then you may assume that that is a 90-degree angle. If you don't see it, you can't just say, oh, it looks like it's 90, so I'm going to say that's what it is. Okay? You can't just assume that it's 90 degrees unless you see that little box. Okay? That means, and you'll see that on squares, you'll see it on rectangles. Okay? When you see that, it tells you it's forming a 90-degree angle. An acute angle measures less than 90, but more than 0. Less than 90, but more than 0. Okay, then we have our obtuse angle, which measures more than 90, but less than 180. And our straight angle, which measures exactly 180 and looks like a straight line. Now, remember that a straight angle doesn't have to just be left to right. It can also be up and down. All right, complementary angles. And this is probably the most missed question that we've seen before when you guys take TACs, when we take STAR, when you take CBAs, is the difference between complementary and supplementary angles. Complementary angles are 2, really, or more angles whose measures add up to 90 degrees. Right? So this right here, these 60 and 30 would be an example of a complementary angle, because if we added 60 plus 30, we would get 90. Okay? Supplementary angles are 2, really, or more angles whose measures add up to 180. So if I added 135 and 45, I would get 180 degrees. Supplementary angles. Now, I will show you my little trick to remember these. So if I write out complementary, I'm just going to write out the COM, and I'm going to write out the supplementary, which looks like sup. Okay? If I take a line here, what does that look like? 90. If I do this, now I have 180. Okay? That's my trick to help remember that. So if it's complementary, you have your C, you make it a 9. If it's supplementary, you have your S, and you make it an 8 for 180. Okay, that's my trick. So let's do a practice with the complementary angles. So when I say find the complement of each angle, we just said complementary angles equal what? They equal 90 degrees. So if you're given an angle or given a degree, okay, and you want to find the complement to it, what do you think? How do I think you'd find that? Find the number that adds up to 90 with that number. So the opposite of that would be? 68. No. How'd you get 58, Bryce? Okay. I'm looking for the opposite of addition here. What's the opposite of addition? So I could subtract what?
90.
Thank you. I could subtract 90. No, we're going about that the hard way. 90 minus 32. Okay. And I would get 58, which would be the complement to a 32-degree angle. Okay. So go ahead right now and on your own find the complement to B, which is an 88-degree angle. Okay, so to find the complement of that 88-degree angle, we would do 90 minus 88, which is 2 degrees. Very good. All right, so on this page, now you've got find the complement of each angle and find the supplement. Well, no, you've already done this, so don't do this again. Don't do, oh, I went back. Too much. Ignore me. Yeah, do the find the supplement part. So you don't have to find the complement, just find the supplement. Okay, so hopefully we found that the supplement, which means 180, okay, 180 minus 130, you should have gotten a 50-degree supplement. And then for 45 degrees, we do 180 minus 45, and you should have got a 135-degree supplement. How'd we do?
Good.
Good? Okay, so these are adjacent angles. Adjacent angles are next to. Okay, so if you're adjacent to someone like at your table, your shoulder partner would be someone that you were adjacent to because you're next to them. Okay, they share a common ray, which is this middle ray. Okay, so this would be the ray that they share right here. Okay, and so the pair, like to name it a pair of adjacent angles, if you're ever asked to do that, on this first one, it would be angle NAB would be adjacent to angle BAK. Do you understand? Because here's one angle, there's one angle, and then your other angle is right here. And together, how many degrees are those angles? 180 together. Okay? So on this one, the adjacent angle would be angle OSR. That's one angle. And then adjacent to OSR would be angle RST. All right, when two lines cross, they form vertical angles. And vertical angles are across from each other, and they share a common vertex, okay? So, for example, which ones in that first one would be vertical? Who could tell me? Ryan? One is the actual problem. So which two angles in the first one are vertical angles? So AGC, okay. Let's look here. So it's really ADC. Okay, and then what would be a vertical angle with ADC? GDC, not GDC. It'd be GDE. That E is a little bit far out, but it would be this one. Yeah, that E should be right there. Okay, so it'd be this angle here would be vertical to this angle here. Why? Because if it was this angle or this angle, those would be adjacent angles, not vertical angles. Okay, so in number 2, that E, I think that E is standing for this one and that one. It's on both sides. And the F goes with the vertex here. Okay, so on the second one, who can tell me what the 2 vertical angles would be on the second one? Samantha. So let's say NFH. That F needs to be the middle number. Okay, and then what else? Not BFN. Bryce? Nope, that's what she just said. BFN wouldn't. BFN would be adjacent. Ashley? BFE. Those are vertical because they're across from each other. Okay, so really a good way to think about it is they're not going to have, one of their rays is not going to touch one of the rays from the other angle. Okay, so they don't have any rays that share. That's all.